Number 1, so which of these equations represents the relationship between B and F? So Priya has a recipe for banana bread, and she uses 7.5 cups of flour to make 3 loaves of banana bread. Andre is going to follow the same recipe, so he will make B loaves of banana bread using F cups of flour. So on our multiple choice, we see that they all are B equals, which means that we're going to have to find our unit rate for cups of flour. So how much bread can we make per cup of flour, since we're multiplying by flour here? So since it's B equals, so banana equals, we'd want to do the banana bread divided by cups of flour. So bread divided by flour. And we have 3 loaves of bread. We use 7.5 cups of flour. So we want to divide that, which when we do, we will get 0.4, which is 2/5. So therefore our answer would be B. Okay, and then for C, it's using the reciprocal of 5/2. So in order for this to be the correct constant proportionality or unit rate that we would use here, it would have to be F equals 5/2 times B. But since it's not, B is our only correct answer on this one. Okay, so we have a percent error problem. It says Diego measured the length of a pen to be 22 centimeters, and the actual length is 23 centimeters. So which of these is the closest to the percent error for his measurement? So percent error, again, is your estimate minus your actual amount. And then we divide that by the actual amount. And then we're going to multiply by 100 to change it to a percent. And then we want to use the absolute value of these numbers. So that means if we get a negative answer, we're going to use the positive value because -4 is 4 units from 0. So that's all these bars mean. So our estimated amount is 22 centimeters. It was actually 23 centimeters. So we know we're going to have to divide by 23. So 22 minus 23, we're going to get -1 divided by 23. And again, we want to use the absolute value of that. So -1 is 1 unit from 0. So it would be 1 divided by 23. So when we do 1 divided by 23, we will get 0.0434 and so on. And then again, we have to multiply by 100 to change it to a percentage, which gives us 4.34%. And it says which of these is closest. So we have 4.3 and 4.5, and 4.3 would be closest. Okay, on number 3, a car is 180 inches long and a truck is 75% longer than the car. So we want to figure out how long the truck is. Well, looking at our options here, we know the car is 180 inches and the truck is longer than that. So we automatically should know 135 inches is not a reasonable answer. So to find 75% longer, so that means it's 75% of 180 inches longer. So we change our percent to a decimal, so that would be 0.75. We're looking for 75% of 180, and of means multiply. We have to use the decimal form of our percentage. So we have 0.75 times 180, which is 135 inches. But we have to remember to go back and add that to our original distance. So we had 180 inches plus the 135 inches, which gives us 315 inches. So this would be our answer. So another method you could have used, if we know the car represents our 100% and it's 75% longer, so our truck is 175% of 180, so of the car. So we could have multiplied the car's distance or length by 175%, which is 1.75 as a decimal, and that would have given us 315 inches and saved us a step of having to go back to add. Okay, so on Elena's running speed, for speed, we usually use our distance per time. So we'd want to divide distance divided by time. So distance divided by time. Well, her distance is 1/4 mile, or that's the distance of the track. So 1/4 mile divided by, it takes 1/20th of an hour for each lap. So divided by 1/20th. So you could type that in your calculator, or if you're working it out on your own, we know that to divide, we change to multiplication. And when we change to multiplication, we have to use the reciprocal of this. So it'd be 20 over 1. So 1/4 times 20 is 20/4, which also simplifies to 5. So since we did distance divided by time, that's going to tell me my miles per hour. So my answer would be 5 miles per hour. Okay, so for number 5, we're using this information that the store's having a sale and they offer a 20% discount. So if the regular price of a t-shirt is $18, what would be the price after the discount? And again, it's a 20% discount. So we know our price is $18, and we have to figure out what 20% of that is. So 20% as a decimal is 0.2. Therefore, 18 times 0.2 is $3.60. So this is the amount of discount. This is not the price after the discount. So we have to go back and subtract that from 18. So 18 minus $3.60 gives me $14.40. So after the discount, that shirt now costs $14.40. And again, when we're using a 20% discount, that means we're actually paying 80% of that shirt. So we also could have found what 80% of 18 is, which would have given us $14.40 and saved a step. Either method is fine, as long as you know what you're doing. Okay, so it says if the regular price of an item is X dollars, those are supposed to be switched, ignore my typo. What is the discount price in dollars? So if the regular price is X amount of dollars, how would I show the discount price? Okay, so up here we know that we had to subtract our amount of discount from the original, but we don't know our original price, so we're just using X for that. So X minus, and to find this, we had to find what 20% of that original amount is. So 20% of the original price. And this would give me my discount price. Or, like we did up here, I know that if I have a 20% discount, I could just find what 80% of that original price is. So either one of these answers would be correct. Okay. 5C, the discount price of a hat is $18. What was the regular price? So now we know what our price is after the discount, but we don't know the regular price. So going back up here to our equations, we know that to find our discounted price, we could have multiplied the original price times 80%. And then our answer would have to be $18 because that's the price of the hat after the discount. So 80% of what amount is $18? We know if we don't know what we can multiply by, we can just divide. Okay, so it'd be 18 divided by 0.8. And that would tell us what the original price was, which is $22.50. So it was originally $22.50. Okay, Lynn's father is paying for a $20 meal, and he has a 15% off coupon for the meal. After the discount, a 7% sales tax is applied. So first we have to figure out the price after using a coupon. So we can find what 15% of $20 is. That would be one option. Or we could also find what 85% is. So we know that's $3, but since that's just the amount of discount, I have to go back and subtract that. So the price of the meal after the coupon is $17. Or if you had just used the 85%, because 15% off, so that's 100 minus 15%. Means you're paying 85% of that meal. So $20 times 85% would have also given you $17. Okay, so that's just the price of the meal. We have to remember to go back and add our sales tax. So we need to find what 7% of that is. So we know that $17 is our 100% now. So $17 times 7%. But then we have to go back and add that answer to 17. So 7% of $17 is $1.19, which gives us $18.19. Or since we know that we are adding 7% and we know 17 is the 100% now, then we're actually, our answer is 117%, or I'm sorry, 107%. So I could have just multiplied 17 by 1.07, which would have given me $18.19. So it's up to you which method you choose. As long as you follow it correctly, you will be correct. So that's just a personal preference. So $18.19 there. Okay, Tyler's brother works in a shoe store, and he makes a 2.5% commission off of the amount that he sells. Let me scoop this up. So last week he sold $900 worth of shoes. So how much was his commission? So we're just got to find what 2.5% of $900 is. So 2.5% as decimal form would be 0.025. So we multiply that, and I believe it's $22.50. Yes. So his commission was $22.50. Make sure you include your 2 decimal places because it is money. So that 0 is important. Okay. So the store, that same store, bought a pair of shoes for $50 and sold it for $80. So it wants to know what was the percent of the markup. So they sold it for $80, but they purchased it for $50. So that was a $30 markup. So we want to know $30 is what percent of the original amount of 50. So we would just divide. So 30 divided by 50, which is 0.6. And then to change it to a percentage, we multiply by 100. So that would give me 60% markup. Tyler's brother earns $12 per hour, and the store offers him a raise of a 5% increase per hour. So after the raise, how much will Tyler's brother make? So 5% increase, so that means 105%. So you can find it two different ways. So you can find your amount of increase first. So 5% increase. Okay, so 5% increase would be 0.6. But since it's money, got to include that second decimal value. And then we have to go back and add. So 12 plus 60 cents gives us $12.60. Or if you had used the 105%, you would have gotten $12.60. So remember this one right here just represents 100%, which is 12. So that saves you a step of having to go back and add that. So $12.60 is how much he makes per hour. Okay, so this one's the same as the first question, except now we're using cakes instead of bread. So these are all C equals. So we would want to do cakes divided by flour. So we have 4 cakes per 9 1/3 cups of flour. So when I divide that, I get 3/7. And again, I did cakes divided by flour. So that means my unit rate is per cup of flour. Therefore, it's got to be C equals 3/7 F. If this was F equals, then this would be the correct answer. Okay. Here is another percent error problem. So we have a graduated cylinder that had 7.5 milliliters of water. Han measured it and he thought that he measured it as 7 milliliters of water. So we got to figure out the percent error for, for Han. So his measured amount minus the actual amount, and then divide that by the actual amount. So 7 minus 7.5 is negative 0.5. And we divide by 7.5. But again, we have to use the absolute value of this. So it's positive 0.5 divided by 7.5%, which is 0.06 repeating. But then we have to change that to a percentage. So we multiply by 100, which gives me 6.6 repeating percent. So which answer is the closest? And that would be 6.7%. Okay, another speed problem, except this one we have a check all that apply. So if we are doing miles per hour, then we would do miles divided by the amount of hours. So we have 1/3 divided by 1/24. So when we change to multiplication, we use the reciprocal, which gives us 24/3, which simplifies to 8. And so since we did miles divided by hours, that is 8 miles per hour. Okay, so had we used hour divided by miles, it would have been 1/24 divided by 1/3. So when we change to multiplication, the 3 is our reciprocal now, which gives us 3/24, which simplifies to 1/8 because it's just the reciprocal of 8. But it's, if I use the reciprocal instead of miles per hour, it's now hours per mile. So both of these answers are correct. Okay, and then I'll go over the bonus problem real quick. So Jake took his friends out to dinner and paid for their meals. His total before tax and a $10 tip was $28. And we have a 9% tax rate. So we got to figure out what the total amount that Jake paid was. So the tip is added after we add the tax because he's just leaving a $10 tip. So we got to figure out the tax first. So tax is 9% of $28. Or remember, you can also do 1.09%, or I'm sorry, 1.09 for 109%. So that gives us $2.52. Or if you had used this one, you would get $30.50. Because over here we have to go back and add that tax now. Okay, so we have our tax now, but we have to remember to go back and add our tip. So we add $10 to that, which gives us $40.52. Okay, and then that one was a turkey. Has legs. It's a key with legs, but can't open a door. So, all right. So there is the review of your Unit 4 test.